Coming to us direct from, you already have a settlement on Mars, I hear. Is that where you're located, Miguel?
That is correct. We're on the far east. Wait, no. Yeah, far stratosphere office of Microsoft now.
Well, welcome, dude. Well, you are going to do the keynote, so I'm going to just toss it over to you and let you talk, bud.
Thank you very much, Seth. All right, well, welcome to my presentation on .NET Conf. So let me start with where we are right now. I come from Xamarin, a small startup that joined Microsoft a couple of months ago. 400 people small, but we just joined Microsoft. And some of you might or might not know that now Xamarin is free with Visual Studio. So if you're getting Visual Studio now, you can get our products, our Android, iOS, and Mac products, and you can also get them for free on the Mac. One of the nice announcements that Scott Guthrie did at the Build conference was that we've open sourced all the SDKs. Not only we open sourced our Android, iOS, Mac, and SDKs, but we also open source Xamarin Forms. And we also changed the license to the Mono runtime from being LGPL, which had some strings attached, to the MIT X11 license. And also we've open sourced all of the components that we did, all of the components that we could for Xamarin Forms and the Xamarin SDK in general. So there's a ton of open code out there, and we're starting to develop a little bit of a community going here, and we expect a lot of interesting things as iOS 10 gets launched next week. Now, before I got here, for this .NET Conf keynote, I didn't really know what to talk about because there's so much to talk about. We've gone back and forth on this slide deck forever. I have about 120 slides that we have to get through in the next 30 minutes. So I did a quick poll this morning to figure out what we're going to talk about today. And I think that the results are in. We're going to spend most of the time talking about the linking code, which I think it's a key element of the future of .NET applications. And maybe we'll touch on the other ones. But so let's get started. I'm going to touch very briefly on the state of the platform. Then I'm going to talk a little bit about the future of the platform, and maybe we'll discuss some secret things. So now, I'm not going to say things are secret. You're just going to have to pick on them, right? So you better pay attention, because I dropped a few secret nuggets in the slides. In some cases, if you zoom into the picture, you'll notice that I used an alpha blended image there with the information, or I'm using a slightly different white. And sometimes I'll send signals for you to know. So before I get started, the state of the platform, it's important for you to know that Xamarin typically releases, we have these major releases during the year. They usually happen 2 to 3 times where we include new features, but mostly we're driven by major upgrades on the platforms that we support. That is iOS and that is Android. So whenever there's a new version of iOS or Android, all the team works to deliver you all the tools and the SDK support that you need so you can target the latest features in these operating systems. And this is something that we take a lot of pride on. We like to call it same-day support. So as soon as the official SDKs go out, the official SDKs from us come out. Additionally, we do these service releases that contain bug fixes, and we do those usually in a monthly cadence, sometimes bi-monthly. So it really depends on how many bugs we have on the product and things that people want to do. So the most important thing is that right now we announced that Evolve, our major release. We call this cycle 7. It's our first major cycle that we've pushed, and we had a public preview. It's called the release candidate. We had it Evolve. We tried to get as many bugs as possible. And I have to say, in the whole history of Xamarin, this was the first release where we ship with 0 known regressions. So after the entire beta process, the entire release candidate process, we managed to get 0 regressions into the product with a ton of features. I'm sure a few bugs are there, but none of them are known regressions. So thank you very much for your help. And what is interesting to us is there's just a ton of things in there, but one of my favorites is the work that we did in Xamarin Studio, both to integrate Roslyn, to ship a dark theme and redesign the entire UI. And also, you might have noticed that this is the first time that we ship officially tvOS support. Now, there's a lot of stuff on cycle 7, and judging by the polls, you're not that interested in knowing what is the state of the world today. So I'm gonna gloss over that, and instead I'm gonna ask you to check the blog post on blog.xamarin.com, which should be coming up either now or in a couple of minutes with all the details of the release. We're very excited. If you go to your updater and you update, you'll have all the new bits on your machine. Now, there's a couple of things that we've been previewing for a while. These are long-term projects that are not ready to be shipped. These are projects that we're actively working on, and we solicit your feedback, or we give early releases to get the features out into people's hands. And they're not finalized. Sometimes we still change the UI. Sometimes we change the APIs and so on. I want to talk about a few of these that are very interesting that we've developed in the last year. This is probably one of my favorites. This is called Skia Sharp. There's a lot of interest in our community to have a high performance, high fidelity graphics, 2D graphics library across all of the .NET implementations. And what we did is we surveyed the space, and we wanted to have an API that rendered exactly the same no matter what the platform was, and was able to take advantage of all the native features, of all the native capabilities of the target platform. So we surveyed the space, and what we wanted, I mean, just as a reminder, we wanted our Android developers and our iOS developers to be able to write their 2D graphics code once, because up until this point, people on iOS had to use core graphics, people on Android had to use the Android API, people on Windows had to use system drawing, and we didn't really have a consistent experience across the board. While we try to emulate system drawing, the emulation is not perfect. That's why I'm talking about high fidelity. So what we did is we took Google's Skia library, which is the same 2D graphics library that powers every single pixel that you see on Google Chrome and every single pixel that is displayed on an Android device. So this is a well-maintained, actively developed, highly performance 2D graphics library, and it draws from the display PostScript graphics model. And in some cases, it can be GPU accelerated. It's available as a convenient NUGE, so you can take a look and take it for a spin. We are happy with the API, but it's a preview, so things might change. But we're very happy with the results and very happy with where it's at. The next thing that we've been previewing for about a year and a half now is our Xamarin Profiler. And it had a rough upbringing, but we are now very happy with the state that it's at. And you get allocation profiling, memory profiling, two gorgeous UIs, modulo that icon that I think we need to change those icons. That's very old style stuff. But what is very interesting about the latest previews of our Xamarin Profiler is that now we do cycle detection. And this is a feature that a lot of our developers, in particular in Android and iOS, have struggled with over the years. And the reason is that when we integrate the garbage collected universe with the reference counted universe of iOS or the other garbage collector from Android, there are a few scenarios where we create what are called strong cycles. And these are cycles that need to be manually broken up. Usually use a profiler to find it, but it is annoying. It is annoying to find that. With the new profiler, we added a new tab called Roots and Cycles. And when you go to the Roots and Cycles, it will show you all the cycles that introduce these strong cycles that the garbage collector cannot break on its own. So now, instead of spending countless hours trying to figure out why it happened and instrumenting your code and randomly sprinkling weak references left and right, you just go to this view and you get a view of the strong cycle. So we're very excited about launching cycle detection. Second, our iOS simulator, we've demoed this at Build. There's new builds of this available constantly. You should check it out. Xamarin Workbooks. We are incredibly excited about the future of interactive C# with Xamarin Workbooks. We've collected a lot of your feedback, and I'm happy to announce that we will be adding UWP support. So this was one of the gaps in Xamarin Workbooks that we hadn't quite solved. And now we have the recipe to be able to support UWP. This is exciting to us because HoloLens is powered by UWP. So we do need to bring that in. So you'll be able to not only use the Urho 3D library, but you can also use other very interesting 3D libraries like the Wave Engine library for C#, and they've already been doing some demos of these with HoloLens. So very excited about this, and also about the future of, in general, of workbooks as a way of documenting your API and document your learning. It's not only a tool to experiment and exploring, it's also a tool for creating documentation that you can share with your team. So you experiment, you learn, you edit, and you share with the rest of your team. There's this saying in the open source world that an application is not complete until it includes an email client. We will not rest until this is part of Outlook, and every email that you send is an interactive C# session. I'm just kidding. I'm just kidding, guys. And of course, the Xamarin Inspector, which extends the workbook system to allow you to take any live Xamarin app and inspect it in the same way that you would inspect a web application. So you're able to connect to a live app, you're able to explore its hierarchy, you're able to explore the user elements in the UI and modify the application live. Then, our last preview that we have is our Xamarin Forms XAML Previewer. As of today, it currently only supports Xamarin Studio, but we're hoping that by next week, we will have the preview available on Visual Studio as well. Now, I don't know how we're doing in time, but let me tell you what is going to keep us busy this fall. Because some of you always ask us, what are we up to? And this is what we're going to be working on. For us, the summer is probably one of the busiest times of the year. So while all of you go on vacation in Biarritz and the Caribbean and the Virgin Islands, we have to stay back home and work nonstop to support the operating systems that typically launch in the fall. That is, in this case, I think it's safe to guess that iOS 10 is coming out. Android 10 is already in third preview. So we typically spend the summer working not only to buy, but I'll also add IDE support and add the editors and property managers and resource management and all kinds of other things to fully support these operating systems. Second, we are complementing our Visual Studio add-in with Mac support. That means that you can finally have a solution that includes not only your Windows desktop apps, but also your Mac apps. You no longer have to switch to the Mac to do the work. You can develop your shared code base from Visual Studio and even compile the Mac pieces on Visual Studio without breaking, which has been an issue that we had with our users in the past, that they had to use 2 machines and 2 IDEs constantly. Not sometimes, but constantly. So now everybody in the team can just get this for free as well. We're also adding ASP.NET Core support to Xamarin Studio. You've seen a nice preview on my Twitter feed a couple of days ago. And of course, something that is very close to our heart is adding localization, which before we joined Xamarin, Microsoft, we couldn't really localize. It's an expensive proposition, but we're adding 13 languages to all of Xamarin products, and we're also making them accessible, which it's something that is very close to my heart and the heart of many of the developers at Xamarin. Now, let me talk a little bit about our plans for the future. So by now you might come to the realization that Microsoft has now 3 IDEs, and I'm gonna sip a little bit of this while you think about this. Right. So the idea is, how do we bring these guys together? How can we share the engineering effort between these 3 IDEs? You got Visual Studio that runs on Windows. You got Visual Studio Code, which is cross-platform, and you got Xamarin Studio, which is cross-platform. But there's a tremendous amount of code that has to be written for 3 entirely different code bases. So right now we're working with the other teams to figure out how to share code and how can we benefit all of the IDEs at once, right? So, let me share with you some of the things that we're doing right now. And I'll just tell you about the things that are very obvious right now. The first one is we're sharing Roslyn. So today, when you launch your Xamarin Studio, you'll get Roslyn, which is used not only for code completion, but it's also used for formatting, for refactoring, for code analysis. We use it for workbooks, and we'll be using it as the compiler that Xamarin uses as soon as C# 7 ships. The nice thing about Xamarin Studio is it runs in 64 bits, so we have more memory than the entire civilizations of the Aztecs. So you can run Roslyn very, very comfortably with Xamarin Studio. The second piece is MS Build went open source and it became cross-platform. And it's taking the place of Mono's existing Xbuild. Xbuild was our implementation. We've been collaborating with the team that works on this, and we're very happy to report that we now have it building a lot of our projects with MS Build. There's still a lot of work to do, but we're switching this compilation engine. Finally, the reason why we were able to demo a couple of days ago ASP.NET Core on Xamarin Studio and debugging with it is because the Visual Studio Code team designed a very nice, those guys are very good architects. They designed a very nice protocol to speak to an external debugger. And what is nice about this protocol is that they've implemented this for .NET Core. But this protocol can be implemented for other languages. So what we did is we implemented this debug protocol that fits very nicely into Xamarin Studio, and that is how we got Xamarin Studio to debug the core CLR with ASP.NET Core, not just with the Mono engine. Now there's more work left to do there, but what is interesting about this design from the Visual Studio Code team is that you can actually debug anything that Visual Studio Code will be able to debug in the future. And if you develop a new language, like NIM or whatever language or D, you can just build a debug engine that speaks this protocol and will be able to debug you from within the IDE, VS Code or Visual Studio or Xamarin Studio. Additionally, they've also designed a very similar approach to this. You've seen OmniSharp, but the same concept behind OmniSharp, which is, what if we take the language service out of process and run it outside of process? And if you follow with detailed VS Code, you'll know that they're making a language service for TypeScript and JavaScript. And this is how we're able to bring together all the capabilities of the really good capabilities of editing TypeScript and JavaScript into Xamarin Studio as well. So for those of you that prefer an IDE, that would like to have an IDE and maintain both your backend as well as your mobile frontend, we'll have a one-stop shop for you to create a new solution, get your backend, get your thing deployed on the backend on whatever cloud you want. I mean, of course, we recommend you use Azure, but you can deploy this anywhere you want and have your frontend and target and build a frontend on any language that you want. Now, let me switch gears a little bit and talk about how we're improving cross-platform development. Now, we have very little time, so I'm going to go very fast. So over the years, the .NET API that you love and learn, that you love, has had a set of APIs. The dark orange represents the base class libraries, and on top of these base class libraries, there's a number of programming models. So traditionally, you've got Windows Forms, WPF, and ASP.NET. With WP, the .NET API surface actually was reduced, and a lot was put on the programming model. And with .NET Core, this API surface somewhere in between, and one of the most popular programming models right now, application models, is ASP.NET Core. Meanwhile, Unity adopted Mono and has their own Surface API, and they have another subset of the .NET API. And of course, Xamarin had 3 different programming models: Mac, Android, and iOS. There's a few more missing, but we had our own implementation of this stack. So the way that you typically share code between this is that you target the intersection of all these things. So essentially, you target the least of everything, right? This is what they're called portable class libraries. And that means that if you want to share code across all these platforms, what you had to do was come in with a machete into your code base and remove everything that wasn't defined in this intersection, right? And there were different intersections, and it was always a little bit confusing. So what is very interesting is that the work that is happening now with the .NET standard is essentially we said, why don't we take a look at this, and why don't we just expand all of them to have a very comprehensive API surface? So essentially, the .NET standard brings a very comprehensive API surface across the board so that you're no longer limited with these tiny little APIs. So that's the .NET standard. Now, this only addresses the what's in the base class libraries. But what about many of the device-specific features in the platform? So for example, there's all kinds of different libraries. For example, I showed you just a little bit ago, Skiasharp, which is a 2D graphics library that you can use on multiple platforms. And you need to have native code on each platform. Or SQLite, that's another great example. It's different on every platform. Or barcode scanners. ZXZync actually has barcode APIs across all the platforms. And the question is, how do you share code with these things? Now, you don't necessarily want to put all of this and all the burden of this to design it on the base class library. So what happens is you typically say, I want to surface this API that everybody can use. So that means that your shared code across platforms can use this stuff. And this is the example that we're doing with Skia Sharp, right? Now, for the implementer, for people like Seth, who's looking very, I have a live feed of Seth here, because he's looking a little bit concerned. So as an implementer of somebody that has to distribute support for Skia Sharp, essentially what you have to do is surface an API, surface this API that exposes the same thing across all platforms. And then behind the scenes, you have multiple implementations. In Skia Sharp, it's very clear the implementation is the native library and a few different API entry points. But for other cases, it's a lot of managed code. And it just happens that you have to manually create the intersection API. You have to manually place the binaries in the NuGet package. You have to manually test it on all these platforms. This is very error prone. Now, for most of you, for the general purpose libraries, what Xamarin has done over the years is we've built components and plugins that do this for you. And we have about 50 of those. And the challenge is that this requires really a dedicated stuff, right? This is called the bait and switch approach, where you take one API and you use different native capabilities everywhere. It's a great technology, it's a great idea, but it's a tedious process. And in Xamarin's case, we have a dedicated staff that does that. In fact, we have a guy that all he does is build bait and switch libraries. We call him Mr. Bait and Switch. And this is very cumbersome. This is a problem. So what we've been working on is this thing, which is, I don't have a preview for you, but I want to introduce it today. It's called the Nugetizer 3000. Now, the Nugetizer 3000, it's a very simple idea. It's a new project type. And I don't know if Microsoft's going to let me call it Nugetizer 3000, but you go into Visual Studio, at least it will be called that in Xamarin Studio. But you go into your IDE, you create a Nugetizer 3000 package, and then project. And then in that project, you go to references and you reference your other projects. So you reference your Android project, your iOS project, your Windows project, your usability project, your Mac project. You just reference them all. And then you go to the properties pages and you fill in a form. This is my favorite library. It does this. This is version 1.0. You hit build, done. We compute the API intersection. We package the NuGet for you. And if you're good, we'll publish it for you.
Nice.
So the Nugetizer 3000, it's coming. We've started work on this based on some Microsoft code that that was already open source, and then we're complementing it with some of our own stuff. But Nugetizer 3000 basically solves a problem that every developer has. Now, let me talk to you very quickly about .NET APIs. One of the things that we do at Xamarin is when you ship applications into mobile devices, you don't have a lot of space, so you cannot afford to ship 20 megabytes, 40 megabytes of .NET code into your application. So typically what you have is you have a little app like this. In this case, it's called myapp.exe, and you have a couple of libraries that you reference things. So realistically, what happens is that you have a couple of codes. Like, for example, myapp.exe references system object and maybe you're calling a method from system.xml, and system.xml calls some stuff from MS-Corelib. So the reality is that your app doesn't need all of these three boxes, right? So what we do is we use a linker process that essentially performs the role of a garbage collector, but instead of garbage collecting your memory, it garbage collects your code, right? So what we do is we take only the pieces that you use and anything that is referenced, and we put it together in a nice package, right? So this is what the mono linker does. Now, Microsoft calls this technology tree shaking. And usually what you do after you have your binary, you add some assets, and then you add your config files, and you have a full and complete application ready that you can ship. Now, the basic of the linker are essentially that you can let the linker run and it will do an okay job, right? You can configure it further, but by default, the mono linker is very conservative. It will keep everything even remotely that you need, right? But you can tweak the configuration and say, I actually want the linking to take place in this way. I won't get into the details, but there's a couple of very interesting features. You can inform the linker, hey, this static variable called environment running on Windows, assume that it's true or assume that it's false, and it will perform that code elimination for you. But additionally, you can implement your own steps. You can teach the linker what to do. So let me show you what we do in iOS. In the case of iOS, we have 26 custom steps that actually are there just to remove junk, right? So there's a lot of code out there, and we know from your application and inspecting your application that there are certain pieces of code that you won't need. So let me show you just 3 optimizations that we perform on iOS. So in iOS, we generate this sort of code. This is the code that you use, this part of UI table view, and it's a method called rec for header in section, right? It takes a parameter, and the challenge here is that the way that the binding works, it needs to cope with subclasses. It needs to cope with calling conventions that are different in the device and on the desktop operating system. It has to deal with 32-bit and 64-bit code. So this is the code that we generate. And as you can see, it's a lot of junk just to call one method, right? You look at this thing, you decompile this stuff, and you have a heart attack. This is incredibly inefficient. So we do this because it's easier for us to maintain and debug code like this than it would be to generate multiple versions of the library, one per mode. So here's what we do. So first, our compiler determines that this is not subclassed. So it's gonna inline that thing, and it's gonna kill all that code. So our linker already removed all that code, right? Next, we can determine whether this is running on device or in the simulator. So we can eliminate completely one of the 2 code paths. Third, we determine whether this is running on 32 bits or 64 bits. Dead, right? All of this is happening at linking time before you even compile the code to deploy it to the device. Next, we figured this is a release build. We don't need to add any of these debugging capabilities. So remove all of these debugging capabilities from the generated code. Done. Third, we realized that this call to an API, the selector.getHandle API call, actually could be in line with a constant that this would look up, and this actually works with the native compiler to eliminate this thing. So this method invocation actually, and we're big fans of doing these intrinsic operations. Mono is big fan of doing intrinsics. Gets turned into a constant. So the method that you call ends up being essentially, after inlining, it becomes a direct call to the underlying infrastructure. So this is how the linker works. And the nice thing about this is it's an extensible model. So it's not limited just to the code that you see. So as you're thinking about how the world works with these larger libraries, you have to think, what can the linker do for me? Because there's so many opportunities for reducing the code that gets executed when you get the link applications. Anyways, this is my update on where we are with Xamarin today. Cycle 7 is here. Please go download, install, and James Montemagno comes right after this, so he's gonna talk a lot about Xamarin. So have a nice conference and enjoy.
Awesome. This has been great, Miguel. Thanks so much for spending some time with us. Thanks so much for watching. We have James coming up next.